This is final exam packet number 1, and in this video I'm going to go over problems number 3, 4, and 5. Alright, number 3 and 4 are related, so if you just skim through it, we know we're looking for standard deviation, and down here we're looking for mean as well, and it's all about these two data sets. So let's start with number 3. Which data set is the most spread out? Use the standard deviation to determine which one is the largest spread. So remember that we learned that different measures of spread was standard deviation, range, and interquartile range, or the IQR. In this case, we want to look at standard deviation. So for standard deviation, you could do it by hand. We have a whole packet that shows you how, but it's so much easier to just plug stuff into our calculator. So I'm going to go to Stat, I'm going to edit my list, and I'm going to plug in data set number 1. So I have 80, 76, 60, 77, 57, 82, 16, 66, 86, 70, 67, and 72. From there, I can just do my one variable stats again. I hit enter, and here we have standard deviation. Remember, it's our sigma, our lowercase sigma, and it's going to be 17.60. So I'm just going to write it down here. Our standard deviation is 17.60. Down here, they're asking us about the mean for these data sets, so I'm just going to copy down the mean as well so that we can use it later. And the mean is 67.42. I'm just rounding. So our mean is 67.42. Alright, so now let's do the same thing for data set 2. I'm going to go back into my list and I'm going to edit. So I have 86, 73, 36, 64, 86, 52, 45, 40, 54, 75, 59, and 82. I go back into my calc and I run the one variable stats, and here we have our mean being 62.67 and our standard deviation 16.99. So I'm just going to write them down. Our standard deviation was 16.99, and I'm just rounding, and my average or my mean is 62.67. Okay. Now let's answer the question. Which data set is most spread out? So remember, the larger the standard deviation, that means it's further away from the mean. That means it's more spread out. So here, 17.60 is larger than 16.9, so that means that data set 1 is more spread out. So data set number 1 is more spread out. Okay, so remember, the larger the standard deviation, the more spread out, the smaller, the less spread out it is. Okay, so now let's answer number 4. Using the same data above, how many elements in data set number 1 are more than one standard deviation above the mean? So if you remember our, let me draw it a little bit higher. If you remember when we talked about normal distribution, we said that our mean was always at the cusp of our little mountain. So here we have, if we're looking at data set number 1, we have 67.42. And we said that one standard deviation could be either way. But here we're just looking above the mean, so let's just worry about this one. So 67.42 plus 17.60 gives us 85.02. So we're looking for all the elements, all the numbers that are above one standard deviation, so that are above 85. So if we look up here, the only number that's above 85 is 86. So that means that we have one element above one more than one standard deviation above the mean. Okay. For if it asked you that is more than one standard deviation from the mean, then you would have to look above and below. So you would have to look below 49.82. So it's just 67.42 minus our standard deviation, and you would see that 16 would be below that. So 16 and 86 are more than one standard deviation away from the mean, but only 86 is above the mean. All right, and for section B, we're going to do the same thing, but now with data set 2. But now, how many elements in data set number 2 are more than 2 standard deviations above the mean? So we're going to do the same thing. We have our normal distribution. We have our mean being 62.67. And we have 1 standard deviation, and I'm just going to look above the mean. So I'm just working this way. 1 standard deviation is 62.67 plus 16.99, which gives us 79.66. 2 standard deviations would give us 93.98. So we want all the numbers in the data set that are above 93.98. So if we look here, none of them are. So no elements. Okay. These calculations are helpful when we're trying to see if our data is indeed normal. And these drawings are just helpful because it helps us remember when we learn about normal distribution and what 1 standard deviation away from the mean means. Okay. All right. Now number 5. The following data set represents geography quiz scores from 1 class. What are the mean, median, and mode of this data set? Explain your reasoning. So here, our mode is easy to find. We know that 4 people got a score of 11. So and that's the most, that's the highest. So therefore, 11 is going to be our mode. To find the mean and the median, we have to list all these out. Here, this is telling us that 1 person got a 14. 2 people got 13s, 1 person got 12, 4 people got 11, 1 person got a 10, 2 people got a 9, 1 person got an 8, 3 people got 6, 2 people got 5s, 3 people got 4s, 1 person got a 3, and 1 person got a 1. Okay, so to find the mean, you're going to add all these up and you're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We have 22 numbers, so you would divide by 22 and we would get our mean to be 8. You can also, oh, no, that's for median. Now for median, you just start crossing out here or in your graph. And you find the center number between 8 and 9. So that means that 9 plus 8 divided by 2, we get a median of 8.5.